Week 6, Lab 1. This is my resource on proving to you the distance from the focal point to a point on the outside of the ellipse back to the other focal point will always equal the length of the major axis. So here today I made little animation using circles, lines, segments and points. But I made this to prove to you the distance from F down as far as H, which is here rotating around our ellipse, back to G will always equal the length of our major axis. So here F and G are our focal points and H is a point on the curve. It's important to know these lines move around the focal points 360 degrees, but if you join them to any point on the ellipse, it always equals the length of the major axis. You can see here now, G and H, the length of the line is reducing. But once it comes as far as B, the line starts extending out and F to H starts reducing. But once it comes around by this point, it starts increasing and H to G starts reducing again. So this just shows down here on the right hand side that our major axis is 12 centimeters long. This shows the distance from, at this bottom thing here, total distance from F to H and G to H. It always equals 12 here. If you can see, it's always consistent. So F to H and H to G will always equal 12. But the thing that changes is the distance from F to G and G to H. But the distance, if you add these two together, will all consistently stay at 12. And this just proves to you that the distance from a focal to anywhere on the outside of an ellipse back to the other focal will always equal 12.